All right, Algebra 2, Lesson 35, Solving Quadratic Equations 1, I guess. What does it say? Felt like it said 2. Nope, it's 1. All right, so looking at it for the first time, I guess. Every quadratic function can be written in the standard form. The standard form of the quadratic function is y, or f of x, equals ax squared plus bx bx plus c. Okay, so a and b represent coefficients to x, and c represents the constant. The zeros of the function are the x values that make f of x equals 0. So to find the zeros of a quadratic function, solve the related equation. So solve ax squared plus bx plus c, but not like this. We will solve it as ax squared plus bx plus c, and we set it equal to 0 and then solve. And I should get two solutions. Actually, there's three different possible scenarios. Either I could get two solutions, meaning that my graph of my quadratic function is going to cross the x-axis in two places. It might only cross it in one place, which would be the vertex of the parabola, or it may not cross it at all, meaning that it's either above or below the x-axis, far enough that the vertex nor any of its sides is actually going to touch the x-axis. So there are three possibilities. Either there's two answers, there's one answer, or there's no answer in terms of the zeros. All right. Many quadratic equations can be solved by factoring and applying the zero product property, which says that if a product is 0, then at least one of its factors is going to be 0. If we let a and b be real numbers, what we see up there at the top, if a times b equals 0, then a equals 0 or b equals 0, either one. Okay, so we would factor and then solve. These are what these three scenarios look like. So if I took my equation that ax squared plus bx plus c, and I plug that into the y equals portion of my graphing calculator and let it graph, I'm going to see something that may look similar to one of these three graphs, which is going to tell me, am I getting one solution? Am I getting two solutions? Am I getting 0 solutions? So this first one here, because that blue line doesn't cross the x-axis anywhere, then y equals 0 nowhere. I don't know if you remember, I believe I talked about it with this class. The x-axis, do you guys remember what the equation of the x-axis is? Y equals 0. So that's what we're talking about. Because the function was f of x equals, or y equals ax squared plus bx plus c. And if we wanted to solve for the zeros, we were saying ax squared plus bx plus c equals 0. Well, what we're talking about is the line y equals 0. So y equals 0 when, right? Well, here it never equals 0. It can't. It doesn't cross y equals 0 anywhere. It may cross at just a single point at the vertex, which means I'll have one time where it can equal 0. Or it may cross it more than once. It drops down below the x-axis and then it comes back up and crosses it again. So there might be two solutions for 0. Okay? So what you might see in the equation where something like this happens is where in the factored form, I might get x plus or minus the same number. So a and a. Okay, that means they're the same thing. So whenever I solve for my zeros, I'm getting x equals positive or negative a, x equals positive or negative a. You know, if it's x equals a and x equals a, then there's only one solution. If it's x equals negative a and x equals negative a, there's one solution. Does that make sense? Okay. All right, so that's when it would look like that. Okay. When a quadratic function has exactly one real 0, that 0 is called a double root of the related equation. So something like that might look like x minus 2, where if I solve for the zeros, what I'm getting is x equals 2. 2 is the only thing that will cause that equation to equal 0. Right? That equation itself would look like let's say x squared minus 4x plus 4. This quadratic function is only going to have one zero solution. Okay, does that make sense? Okay. So x equals 2 is the double root, or 2 is the double root. All right, let's try to answer some questions. Got through that fairly quickly. All right, some of these are easier to solve than others, and hopefully we're familiar with some of this. We have 9x squared minus 64. By this point, I'm hoping that we recognize how to factor this, and we see some common traits and some things that we've seen before. What do we see about 9 and 64? What do we know about both those numbers? They're perfect squares. Do I have an x, just a simple x to the first value in there anywhere? And I'm subtracting the second perfect square, correct? So this is what we would call, can anybody know what kind of answer we're going to get here? The term for it is a sum difference. It's the reason that there's no x value, because it cancels out. And the only way I can get it to cancel out is if it's plus and minus the same thing. All right, so we're looking at the perfect square of 9x squared. What's 9x? What's the square root of 9x squared? 3x and 3x. Well, what's the square root of 64? 8 and 8. All right, so if I work this out in reverse and I FOILed it, I should get 9x squared minus 64. That's my way of testing it, correct? So 3x times 3x is 9x squared, right? Let's see, 3 times negative 8 is what, negative 24x. 8 times 3 is positive 24x, so we can see how those cancel out, correct? And then 8 times negative 8 is 64. There's no x in the middle. I get what I started with, right? All right, but if I stopped there, I would not have answered the question that is asked, because it says find the zeros. So what do I have to do with each set of parentheses? All right, so let's take the first one. 3x plus 8 equals 0. What do I get? What do I have to do? It's not as simple as just subtracting 8 and I'm done. The answer is negative 8, right? Because I have a coefficient in front of x this time. What do I do, John? How do I solve for x in this equation? It's really not that hard, but it's different than what we've done with these. Yep. Subtract 8 from, hold on, from both sides. Okay, so I got 3x equals negative 8 divided by 3 on both sides. So x equals negative 8/3, right? And I can test this, right? That's the nice thing about math, is that I can test this to see if it works. I can take in my calculator 3 times negative 8/3 and then add 8, and if that equals 0, I've done it right. Somebody want to test this for me? 3 times negative 8/3. I'm going to have to put that negative 8/3 in parentheses, by the way. 3 times negative 8/3. I can't just do 3 minus 8/3 plus 8, and I got 0. Okay? All right, now I want to do the other one. Now, the more familiar I get with this, the easier it is to do, right? What am I going to do next, Axel? Okay, I want to make sure that you're with me. I know you kind of come in a little bit later, but what do I want to... On?
Both sides.
Okay, so I got 3x equals 8. Divide by 3. X equals 8/3. So now I could come over here, and I have to do it with the one on the right. I can't come back over here to the one on the left and plug in positive 8/3. It won't work. I need 3 times 8/3. Well, 3 times 8 divided by 3, the 3's are going to cancel out, leaving me with 8 minus 8. 8 minus 8 is 0. So my answers are negative 8/3 and positive 8/3. Does this make sense? Can we do this? Great. All right. Now, 2 is meant to trick you. Does anybody know the tricky part to number 2?
Yes.
What do I have to do before I can actually factor this? Set it equal to 0. How am I going to do that, though? Allison, how do I set number 2 equal to 0? Subtract 15 from both sides. So I'm getting x squared plus 2x what? Minus 15 equals 0. I have to do that first. It has to equal 0 before I can factor it, right? Otherwise, I can't use the zero product property. The next thing I want to do is I want to factor. Okay. What's my first term in each set of parentheses? X, good, because there's no coefficient in front of X. It's a plus minus, so what kind of operation should I get on the inside? Plus minus, very good, because the only way to get a subtraction sign from multiplication is to multiply something that's positive by something that's negative. The bigger number is going to be what? Is it going to be positive or negative? Positive, because the first term is positive in here, right? It has to be bigger. Because I'm going to add a positive and a negative, I have to wind up with a positive. All right, so I'm looking for things now that multiply to be 15 but have a difference of 2. 5 and 3, right? Which one has to be positive? 5 and then 3. All right, now it says find the roots. So I'm going to set each of these terms equal to 0. Good. X plus 5 equals 0. So I should be getting x equals and x equals positive 3. So my roots should be negative 5 and 3. Go ahead and scroll down to the bottom, see what you get. Do you get negative 5 and 3? Yes, okay. All right, now, this next one has you do the whole thing in reverse. Okay? So, this says write a quadratic function that has zeros where it's negative 2/3 and 3. So this is how we do this, okay? I'm going to start with x equals. X equals negative 2/3. Okay? Let's start with that. I want to move everything over to the left-hand side. Okay? How do I move the 3 to the left-hand side? Multiply by 3. So I'm going to multiply by 3 on both sides. That's giving me 3x. So 3x equals negative 2. Well, how do I get the negative 2 to the other side? Add 2. Add 2. So that's 3x. What? Plus 2. And what does it equal? 0. Okay? And I wanted to show it to you that way because I think that you're probably going to have an inclination where you're going to take x equals negative 2/3 and just add 2/3 to both sides and get x plus 2/3, right? Okay, we want 3x plus 2. Do we understand how to get 3x plus 2? All right, because that's going to be part of this, 3x plus 2. Does that make sense? And we're not going to be done, but that's my next part. So we understand how to get there. All right? The next one says, and 3. So that means x equals 3. How do I get the 3 to the other side? Nope. Subtract. Subtract. Subtract 3 from both sides. That's giving me x minus 3, right? All right. X minus 3 equals 0. So I can come down here, x minus 3. Okay? Now the next part, okay, is I actually want to FOIL all of this because it's asking for the quadratic function. Quadratic means I need x squared. So I'm taking what? What do I get? 3x times x, which is 3x squared. What's next?
3x times negative 3.
Okay, what's 3x times negative 3? Negative 9x. What's next?
2 times x.
Which is
2 plus 2x.
positive 2x. Okay, and then
2
2 times
times negative 3 is
negative 3 is negative 6. I'm almost done. 3x squared minus 7x minus 6. And if I wanted to test that, all right, we could go back up all the way through and see, does x equal negative 2/3 and does x equal 3? All right? All right, so it's the whole thing done back in reverse. Okay? Does that make sense? Okay? A little tough, so this is where you want to go back and watch the video. All right, they're setting x equal to a fraction, so actually multiply by the denominator and then subtract or add the numerator depending. Okay? All right. Let's see. What time do you guys get out? 36? 36. If you guys feel comfortable, I mean, number 4, some of these others can be a little tricky. If you want to continue working out some practice problems, we can do that. Or if you guys just want to go ahead and get started, you feel like you got this, right? Number 6, we would need to subtract 58x, or better yet, move everything else over to the left. So add 5x squared, subtract 24, to give me a positive 5x squared to work with instead of a negative 5x squared. Does that make sense? Okay, so I want that leading coefficient, whatever is attached to x squared, to be positive as much as possible. Okay, so be aware of that. Let me see. That's pretty much it. We didn't do 4, 5, or 6. If you want to do any of those, let me know now, or I'll let you go. Okay, are we ready to be done? Okay.